Okay children, today we are doing the part 7, that is under arc properties. We will be doing theorem number 7. Now again let me remind you, the numbers are for our own convenience, so you can't call the theorems by their number. Okay, so now this is a very important theorem and very often used and a very simple theorem. Okay, so the statement of the theorem, so for our convenience we are calling it as theorem number 7, but this is numbering is not fixed. Now this theorem, according to this theorem, the angle in a semicircle is a right angle. Okay, the angle in a semicircle is a right angle. Okay, so that means if you have a semicircle, semicircle is what? The region bounded by the diameter and the semicircle of this region. These are the two segments. Okay, now semicircle is the entire thing. Okay, this half of the circumference of the circle plus let us call chord AB, that is the diameter. A chord which passes through the center of the circle is the diameter. Okay, so now the angle in a semicircle. So let us draw an angle, say ACB. Okay, now angle ACB is an angle in a semicircle, and this angle ACB is subtended by the semicircle AB in the remaining part of the circle, right? According to our previous theorem, this is also an arc, which is not, but coincidentally the arc is a semicircle, half of the circumference of the circle. Okay, so now angle ACB, okay, is the angle subtended by the arc AB, which in this case happens to be a semicircle. Now we have to prove, or according to this theorem, this angle is 90 degree. This is already proved. We are verifying it for your sake. Okay. So now how can we do that? Using our previous theorem of arc property, that is the angle subtended by an arc at the center of the circle is double the angle in the remaining part of the circle. Now here the angle subtended by the arc AB at the center O is angle AOB, which is a straight angle. That means angle AOB is 180 degrees. Okay, so angle ACB is the angle subtended by the arc AB only at any point on C at C in the remaining part of the circle. So angle ACB will be half of angle AOB, or angle AOB is double angle ACB. We already know angle AOB is 180 degrees. So angle ACB is 90 degrees. So let us write it in a proof form. So we have already proved that it is a 90 degree. So now what is given? Given is a circle with center O, that everywhere in every theorem we will have this. Next, AB is the diameter, or you can say AOB is the diameter of the circle. Okay, now angle ACB is an angle subtended by the arc AB in the remaining part of the circle. Do you agree? If AB is this arc, then this arc AB is subtending an angle at point C in the remaining part of the circle. This is the remaining part of the circle. Okay? And angle AOB, okay, that we are considering, we only know AOB is the diameter. Now in proof we will write, there is no need of any construction in this. Now angle AOB, okay, is equal to 180 degrees, which is a straight angle, because AOB is a straight angle, we also call it. Why? What is the reason? Because AOB is a straight line. It is 180 degrees. Since AOB is a straight line, angle AOB is 180 degrees. Right? Now, angle AOB is 180 degrees. But what is angle AOB? We can also consider angle AOB, but angle AOB is the angle subtended by the arc AB, subtended by the arc AB at the center of the circle, right? So, according to our previous theorem, angle implies angle AOB is equal to twice angle ACB. According to the theorem that we learnt earlier to this, that is the angle at the center is double the angle in the remaining part of the circle. Okay, so this implies angle ACB is equal to half of angle AOB. But we have already proved angle AOB is 180 degrees. So if you call this equation 1, or so it follows that implies angle ACB is equal to half of 180 degrees from 1. That is, we have proved in 1 that angle AOB is 180 degrees. Implies angle ACB is equal to 90 degrees. So the statement angle in a semicircle is a right angle is true. We have verified. Now this point C can be anywhere. It can be here also. Suppose there is a point D. Even this will be 90 degrees. This is a 90 degree. If a point E is here, this also will be 90 degrees. So any point on the circumference of the circle, if you take any angle in the semicircle, will be a 90 degree, that is a right angle. It is a very often used, very important. I hope it is clear to you children. Okay.